This is the second part of the further example video lesson on permutation and combination. So now there are two past paper questions taken from the HKDSC paper, right? So let's look at the top question first. We have an 8-digit phone number. It's formed by a permutation of these 8 digits, right? We have 8 digits, 2, 3, 4, 5, 6, 7, 8, 9, 8 digits, right? So first in A part, how many different 8-digit telephone numbers can be formed? So first we have to think about it. Is it a combination or permutation question? Phone numbers. The ordering is important, so it is a permutation question. We want to line up 8 digits out of 8, so the answer is AP8. It goes to 40320. This is it, alright, so there's only 1 mark for this one. Now part B is more difficult. If the first digit and the last digit, they are odd numbers. Alright, so imagine we have 8 boxes, right? 1, 2, 3, 4, 5, 6, 7, 8. Alright. Now the first digit and the last digit, they must be odd numbers. Alright, so let's see what are the odd numbers. 2, 3, 5, 7, 8. These are odd numbers. We have 4 choices for the odd numbers. So we put 4 options in the leading box. Alright. And then for the trailing box, it is also an odd number. But then one of the odd number is already taken. Alright, one of the odd number is already taken in the leading box. So we are now down to 3 odd numbers for the last box. Alright, because from the context of the question, we know that the phone numbers cannot be repeated. It's formed by a permutation of these digits, so they cannot repeat. If you allow repeat, then there will be 4 options here, right? But if there's no repeat, there are only 3 options to choose from for the last digit. And then for the middle, you now have 6 digits, all right? And once again, it's a permutation of 6 digits. So that would be 6p6, all right? And the answer goes to, that's a product of these 3 numbers. And the answer goes to 8640, all right? If the leading and the trailing digit must be odd digit, all right? And then on the next question is also about phone number. It's very similar, right? In the question 44, if we have the first 3 digit and the last 5 digit are formed by a permutation of 5, 6, 6, 9 as the first 3 digits, all right? The first one is made by a permutation of 5, 6, and 9, all right? And the trailing 5 digits, 1, 2, 3, 4, 5, is formed by a permutation of 2, 3, 4, 7, 8. All right. Okay, so how many different 8-digit phone numbers can be formed? All right. When I say a permutation, that is no repeat. All right. It is 5, 6, 9, 9, 6, 5, and so on. All right. We can have this, but we cannot have 9, 9, 5. No, we cannot do this. That's not a permutation of 5, 6, and 9. All right. So that means for the green group, for the leading 3 digits, you have 3p3. So many ways to do that. For the blue group, we have 5p5. So many ways to do that. All right. At the end, we multiply the 2. Multiply, right? Do not use addition because they are independent permutation. What you see in the green has no effect on the blue. What you see on the blue has no effect on the green. So they are independent. Independent options, we multiply them together. So that is 3p3 times 5p5, and the answer goes to 720. Alright, this is the answer. Alright, so these are the 2 past paper questions regarding permutation and combination with phone numbers. With phone numbers, it's easy to see. It is almost definitely a permutation rather than a combination. Let's look at some cases that are more likely a combination, right? Now here is another example. There are 10 players in a basketball club, alright? 5 are chosen to form a team. So how many different teams can be made? If you choose player to form a team without specific role, then it is a combination, alright? Because there's no role in the team. On the other hand, if you have to choose a team captain, an assistant captain, and attack and defend, then that would be permutation. If there are specific roles in the team, alright? Without specific role, you just put them in a bag and just shuffle them. So it is an NCR. So to choose 5 players among 10 In part A, you can choose 10C5, alright. These are the number of teams you can make, and the answer goes to 252. 10C5, okay? That is to choose 5 players out of 10 to form a combination, alright. Now, and then there's a hiccup. We have Jack. Jack is one of the players, so that means we have Jack plus 9 other players. Alright, Jack plus 9 other players. Altogether, there are 10. Now, how many teams are there without Jack? How do you calculate this? Alright. Now, we can rethink the question in this way. We choose 5 players out of 10, but we are not allowed to choose Jack. That means we are only choosing among the 9 players. We choose 5 of them. Do you understand? Can you understand the question in this way? Alright. How to disregard Jack is to not to take Jack into consideration. Alright. Altogether there are 10 players, so there's Jack plus 9 others. To choose a team without Jack, we just choose the team from the 9 players. In other words, the answer is simply 9C5. Alright. We disregard Jack and just pick the 5 player from the 9. Alright. So the answer goes to 126. This is the number of teams without Jack. Alright. So how about the teams with Jack? Alright, now there are 2 ways we can do it. Alright. The first way is, well, we take the answer from A part. These are the total number of teams with or without Jack. Alright. And then I subtract from it the number of teams without Jack. Alright, you take all of them and you subtract those without Jack. So the numbers remaining will be the number of teams with Jack. Coincidentally, it is the same 126. Alright. Or there's another way of thinking, right? To consider this, right, originally there were not Jack plus 9 other players to fill in 5 slots. Alright. But now Jack is already one of them. Alright. Jack must be one of the players. So that means that we are choosing 4 players out of 9 to play with Jack. Right, to accompany Jack. Jack is already taken. Alright. So 1 seat is already reserved for Jack. So that means the answer will be 9C4. Alright. 9 will be 10 minus 1. Alright. There are 10 players, but we do not choose Jack. Jack is already in. Alright. And then we choose 5 players, but we choose 1 fewer because Jack is already taken up 1 position. So this is 9C4. Alright. 9C4 is also 126. Alright. The answer is the same, 126. Alright, so in this last example, I try to demonstrate different ways to rethink the question, to structure the idea into the format of NCR and NPR so that we can put them into calculation. Alright. Now, the next example is very similar to this one. So see if you can learn from this example and try to do the next one. Okay? If you are not sure, you can go back and repeat this part to see, how do we consider with Jack or without Jack. Alright, what are the thinking in the calculation? Alright, so if you are ready, we can go into the next and the last example in this chapter. Alright, so there are 2 different gold coins and 8 different silver coins. Now 3 coins are chosen to put in a box. Alright, so once again, is it NPR or NCR? We put the coin in a box. Is it an NCR or NPR? Right? The answer is it is an NCR question. Alright, if you put the coin in the box, there's no arrangement, there's no ordering. On the other hand, if we line up the coins, then it is an NPR question. Alright, so NCR, remember. So first of all, how many ways are there? Regardless of the color. Regardless of the color, we have 10 coins. Alright, 2 plus 8, 10 coins altogether, and we choose 3 of them. So the answer is 10C3, and it is 120. 120, right? There are 120 ways to put 3 coins into a box from a pool of 10 different coins. Never mind the color. But now in part B, the color becomes important. What if there must be exactly 2 gold coins in the box? Which means that we need 2 gold coins and 1 silver coin. We need 2 gold coins and 1 silver coin. So we choose the 2 gold coins, alright? The 2 gold coins will be, there are only 2 gold coins, so we choose the 2 gold coins. These are the number of ways we can choose the gold coins. And then for the silver coins, For the silver coins, we have 8 silver coins, and we choose one of them, alright, because we need 2 gold coins and 1 silver coin, alright, into the box. So the answer is we multiply these two numbers, and the answer goes to 8. Alright, 2C2 is a 1. Alright, so the answer goes to 8. There are 8 ways we can do that. Alright, to have exactly 2 gold coins. Alright. Now similarly in part C, what if there must be exactly 1 gold coin? If there's exactly 1 gold coin, that means there are exactly 2 silver coins. So to choose the gold coins, we can choose 1 gold coin out of 2. At the same time, we choose 2 silver coins out of 8, alright, and then we multiply them together. These are independent events, so we multiply them together. So 2 gold coins, choose 1. 8 silver coins, choose 2. So there's 2C1 times 8C2. The answer goes to 56. Alright. And part D, what if there must be at least 1 gold coin in the box? Alright, so we have to decipher the meaning of at least 1 gold coin. Alright, what is the meaning of at least 1 gold? There are 2 ways to understand it. At least 1 gold means that unless there is no gold. Alright, unless there's no gold. Which means that unless it is all 3 silver coins. Alright, unless all the 3 coins, they are silver. Alright? If all the 3 coins they are silver, there's no gold. Otherwise, there is at least 1 gold. So unless means 1 minus. Right? 1 is the original number of ways, and that would be in the answer in green. Alright? That would be 10C3. Alright? This is the number of choices you can make regardless of color. And from that, we take away all the 3 silver combination. To choose 3 silver coins out of 8, we have 8C3. Alright? We have 10C3, that is unless. Alright? We have 10C3 minus the all silver coin combination. This is the all silver coin combination. And the answer goes to 64. Alright? There are 64 ways to have at least 1 gold coin. Alternatively, there's another way to understand at least 1 gold. At least 1 gold means that there are 1 gold, 2 golds, or 3 gold coins. Alright? 1 gold coin, 2 gold coins, or 3 gold coins. Alright? 1 gold coin, that means there are 2 silver coins. Alright? 2 gold coin means there is 1 silver. 3 gold means that there's no silver. But you can never have 3 gold coins because there were only 2 gold coins. Alright? So it is just the sum of the answer from part B. We already did that, right? This is 56. We already did that. Exactly 1 gold coin. And then exactly 2 gold coins will be the answer here. Exactly 3 gold coins, the answer is 0. Alright. Now these 3 events, they are mutually exclusive. Alright. It's either 1 gold, 2 silver, or 2 gold, 1 silver, or 3 gold, no silver. So you just add them together. Add them up, the answer goes to 64. Alright. So it's just the same as the previous answer. Okay. So I hope these extra examples can help you understand more on what are the different strategies we employed in handling permutation and combination questions. That is the end of this chapter.